Hello. In this video, we're going to go over how to find the mean of the data summarized in a given frequency distribution. And then we're going to go ahead and compare that computed mean to the actual mean of 57.9 degrees. So here we're given a frequency distribution where we have our classes and then the frequency. Let's go ahead over the theory on how to compute this. We aren't given the raw data, so we're going to need some other formula to go ahead and find the mean. That formula is right here. It looks a little bit strange, but it's pretty straightforward. At the top, what we're going to do right here is we're going to multiply, hence the dot, each frequency, which is represented by the F, and the class midpoint, represented by the X. Then we're going to add the products, and then symbolically that's represented by this capital Greek sigma, which means sum. So after we find all of that, we're going to divide by the sample size, or the sum of the frequencies. So here's an example of what we're going to need to compute. We are provided this information initially. This example is using a different data set, but that's okay. The principles apply. So what we're going to do is find the class midpoint, and the class midpoint is computed from the sum of the lower and upper class limits divided by 2. And then we will literally just take these two numbers, multiply them together, and that gives us this right here. Let's go ahead and do this. Now, instead of doing it by hand, I'm going to show how to use a freely available tool that many students are probably already familiar with, and that would just be Google Sheets. So if we click this right here, we have options to open it in one of these 3 different modes, but we're going to just copy to clipboard so we can use Google Sheets. So if I copy that and go and open up a new Google Sheet by just typing sheets.new, and I will paste it right in here. Let's go ahead and zoom in. So how are we going to do this? Well, just to make sure everything's there, by clicking on that bar in between a column, it'll autofit it. Now, I don't want to have to manually compute these midpoints. Granted, it wouldn't be too hard. So I'm going to go ahead and separate this data. I'll do that by right-clicking and then selecting or adding, right-clicking and adding a new column to the right. I will then select this data, click on data, and then I will go down to split text to columns. The separator we're using is a hyphen. So when I put that in, it'll recognize that there's two columns of data separated by the hyphen, and we're all set. Now, to accurately represent this data, I'm going to say that these are the lower class limits, and lower, and these are the upper class limits. To find the midpoint, I'm going to go ahead and make another column to the right. So these will be the class midpoints, and that is just going to be the value in the A cell plus the value in the B cell. And we do need to put parentheses here. So order of operations adds that first, divide it by 2, hit enter, and you'll even see that it suggested an autofill. So if we just hit the check mark, we now have our class midpoints. Next, we need to go ahead and find the product. So we'll do the midpoints times the frequency. So to do that, I'll hit equal, select the value in column C, multiply the value in column D, now hit enter, and again, it will suggest the autofill. Just a little trick, if we rejected that, and we still need to do this, if we just grab this little dot and drag down, we will have the formula drag down, and you can see even from the formula right there, it essentially selected the appropriate row. So what else do we need? Well, we need the sum of the frequencies. So let's go ahead and sum that together. We need the sum of the products, so that we have that right there. And then to find the estimated mean, so this would be the estimated mean of the frequency distribution. Well, we'll just call it, well, yeah, that's fine. We want to emphasize this estimated more on SEC. We will just hit equal, and we'll take this value, divide it by this value, and we hit enter. All right, from here, let's go ahead and copy that value over, go back here and check that. Okay, a little bit of a mistake. Let's see where we went wrong. I think it's in the rounding. Yep, there we go. So if we round that to 0.3, there we have it. All right, so how close is this? Remember that a frequency distribution is a summary of the data. So we are posed this question: which of the following best describes the relationship between the computed mean and the actual mean? Because we don't actually have the raw data, we can't figure out the actual mean, but they told us it was 57.9. So consider the computed mean as close to the actual mean if the difference is less than 5% of the actual mean. So going back here, the actual mean, well, that was given to us as 57.9. So 57.9. Let's go ahead and round this to, I'll just manually round it. So we could just round, no, let's do it without rounding. So let's find the difference between the two. So we will do the subtract the actual mean from the estimated mean, and we see that the difference is 5.65. Now, what is the percent difference there? So let's go ahead and just figure out the percentage of this in relation to the actual mean. So if we do this divided by, so the difference divided by the actual mean and multiply that by 100, we'll see that it's approximately 9%. So you can see right here that they are not close. So the computed mean is not close to the actual mean because the difference is not less, but more. So let's check C, check answer. Fantastic. So in summary, when we are given a frequency distribution, we have a summary of the data. So we will need to compute the mean, essentially finding some representative value for all of these. So let's use the midpoint. And then we will just plug it into that formula, creating this expanded table. But keep in mind that that might not be near the actual mean. So we have a benchmark of about 5% to see if it's a good estimate. Hope that helps. Give it a try yourself and let us know if you have any questions.